Okay, 1. Like you will notice here in the, but 5. Instruction said earlier, you need to make that coefficient. So like our instruction said earlier, you need to make that coefficient a 1, and the only way you can do that is by taking your original equation and dividing both sides of your equation by whatever that coefficient is. So since your coefficient is 5, we divide both sides of the equation by 5. Okay, so basically you're dividing every term of the equation by 5, and let's see what will that give us. You will end up with 5 divided by 5 is 1, which is what we wanted. So you end up with x squared minus 10 divided by 5 is 2, so 2x, and 2 divided by 5 will stay as 2 divided by 5, or 2 over 5. And of course we know that 0 divided by 5 will still be 0. Okay, so the first thing we had to do was get rid of the 5 on our squared term, because we want the coefficient on our squared term to be 1. So anytime you come across an equation of this form, that's the first thing you want to do, is get rid of that coefficient term. Now we are ready to solve this. So your second step is move your constant term over to the other side, so that you have variable terms on one side, constants on the other. So we will subtract 2/5 on both sides, and you end up with equals negative 2/5. Okay, now look at your coefficient on the middle term, your x term, which is 2. So you will do 2, and then you square it, 2 divided by 2, and then you square it. Okay, so 2 divided by 2 is of course 1. 1 square is 1. So that tells us we are adding 1 on both sides of our equation. Okay, let's go ahead and factor our left hand side, and this will factor into x minus 1. And again, if you're not sure, go back and FOIL x minus 1 times x minus 1 and see if you end up with this expression. And negative 2/5 plus 1 will give you 3/5. Okay, now let's go ahead and apply our square root property, because we are ready to work with it now. Okay, so let's see. By your square root property, you will end up with x minus 1 equals square root of 3 over 5, or x minus 1 equals negative square root of 3 over 5. Okay, now you need to simplify this radical term here. So you will end up with x minus 1 equals square root of 3 over square root of 5, because you can see that neither 3 nor 5 are perfect squares. Okay, so what we will have to do here is rationalize the denominator, because again, remember, you never leave your denominator as a radical term. So how do you rationalize your denominators? You multiply by the denominator itself, because it's a single termed denominator, and you will end up with square root of 15, right? 3 times 5, they have the same index, you can multiply them, over square root of 5 times square root of 5 will give you just 5. And that's how you need to go ahead and simplify your radical term. So that's the same thing that will happen on this side. And we know that since they're both the same, one's going to be positive, one's going to be negative, this guy will end up being negative square root of 15 over 5. So, it's going to follow the same procedure, but that's what you will end up with. And of course, now the only thing to do is move the 1 over to the other side, and you will end up with x equals 1 plus square root of 15 over 5. And same thing here, move the 1 over to the other side, and you end up with x equals 1 minus square root of 15 over 5. Okay. Now, if you want, you can go ahead and try and combine these two terms together. And the only way to combine them together would be to find a common denominator. So, of course, this would be over 1. Okay. So, your common denominator would be 5. Go ahead and you will end up with 5 plus square root of 15 over 5, or x equals 5 minus square root of 15 over 5. Okay. And if you want to check your solutions into the original equation, and you will end up with true statements for both of them, 5 plus square root of 15 over 5 and 5 minus square root of 15 over 5. Okay, so for your original equation, 5x squared minus 10x, this is what your solution set is going to look like. Okay. Take a look at one more example that involves fractions in it, but this time you will notice is 1. Go back, and your squared term has the coefficient of 1, so this time you didn't have to divide by any that your leading coefficient non-zero number into completing the square. You will also see that your variable plus 2 term is on the other, so you don't have to move your constant term. So now what we will do is terms are on one side and the constant, and you're supposed to take its half, right? You're supposed to divide it by 2. So dividing by 2 is the same thing as multiplying the half of 4 over 3, and then you are going to square it. So go ahead and multiply 4 over 3 into 1/2, and that will give you by 1/2. Okay, you're just taking 4 over 6 quantity squared, but we know that you can reduce 4 over 6, and that will become 2 over 3 quantity squared, and when you square it, 2 square gives you 4, 3 square gives you 9. Okay, so when you're completing the square, you will go ahead and add 4 over 9 on both sides of your original equation. So that will be z square minus 4 over 3z plus 4 over 9. On the other side, you have negative 1 over 9, and to that you are adding 4 over 9. All right, let's go ahead and factor our left hand side. So that will be z minus, and let's see, you will end up with 2 over 3. Let me see. Okay, let's give this a try. 4 over 9. We know the factors are 2 over 3 times 2 over 3. And if we factor this into z minus 2 over 3 squared, will we end up with z squared minus 4 over 3z plus 4 over 9? Again, remember, always a good idea to go ahead and FOIL this. And if we FOIL it, we will end up with z minus 2 over 3z minus 2 over 3z plus 4 over 9, and I'm sorry, that should be a z squared, and that will give you z squared. Combine your middle terms, negative 2/3 will give you negative 4/3 z plus 4 over 9, and that is what we were looking for, z squared minus 4/3 z plus 4 over 9. So z minus 2/3 square will work for us, and so that will give us our left hand side. And on your right hand side, you can see they have the same denominators, so you don't have to find a common denominator, and you can just add negative 1 plus 4, which gives you positive 3, and 3 over 9 can be reduced into 1/3. Okay, so you end up with z minus 2/3 square equals 1/3. Apply your square root property, so you end up with z minus 2/3 equals square root of 1 over 3, or z minus 2/3 will give you negative square root of 1 over 3. Again, you're going to have to simplify this just like we did in the earlier example and rationalize your denominator. So if you do that, you will end up with z minus 2 over 3 equals square root of 3 over 3. This will what happen when you simplify this using rationalizing the denominator. So go ahead and try that and make sure that you come up with square root of 3 over 3 as your answer. On the other side, same thing except with the negative sign. Okay, and now all you have to do is add the two terms together. You'll take negative 2/3 on the other side and become positive, and that will give you 2 plus square root of 3 whole thing over 3, because they have the same denominator. On the other side, same thing will happen. You'll add 2/3 on both sides of your equation, and you'll end up with 2 minus square root of 3 and the whole thing over 3. So 2 plus square root of 3 over 3 and 2 minus square root of 3 over 3 are going to be solutions to this equation. So when you're working with fractions, you have to be a little careful, especially when you are trying to factor the perfect square trinomial. So practice a little and you should be able to work with these. Now sometimes you may come across problems that may have imaginary solutions. So let's go ahead and take a look at an example that you may encounter something of that form. So just like we do with every other quadratic equation, you want to do the same thing. Again, you will notice that the term on your squared, your coefficient on the squared term is 1, so you don't have to worry about that. The next thing you do is take the 13 over to the other side, so you're left with m squared plus 4m equals negative 13. Okay, you just subtract 13 on both sides. Now we are ready to complete the square, so we take the 4, divide that by 2 because you take its half, and then you square it, which gives you 4 over 2 is 2. 2 squared, of course, is 4 again. So m squared plus 4m plus 4 equals negative 13 plus 4. You add your 4 on both sides, and your left hand side will factor into m plus 2 squared. Okay, right hand side will give you negative 9 as the answer, negative 13 plus 4. Now this is why you're going to end up with an imaginary solution, because your right hand side is a negative number, and we had talked about these problems in section 11.1, so we're back to that same situation. Now we will apply our square root property, which will give us m plus 2 equals square root of negative 9, or m plus 2 will give us a negative square root of negative 9. Okay, because again, remember the negative on the 9 goes inside the radical by our square root property. Okay, now let's go ahead and simplify the radical term first. Again, remember that I equals square root of -1. So we will go ahead and take the negative outside of our radical by using the number I, and you're left with I times square root of 9, okay, positive 9. Same thing on the other side, m plus 2 equals negative from here, I, because we convert our radical into a positive one by taking the negative outside. And again, you're left with square root of 9. And we know square root of 9 is a perfect square, so we can rewrite that. Square root of 9 will become 3. Don't forget your I. Same thing on the other side. Negative square root of 9 will become 3. And then you have your I term. Now, once you simplify the radical, now you can go ahead and get m by itself by moving your 2 over to the other side, and you end up with m equals -2 plus 3i, or same thing on the other side, move your 2 over, m equals -2 minus 3i. And again, try substituting these answers into the original equation and see if you end up with a true statement. Okay, and of course you should when you check your solutions, and therefore we can say that our solution set is -2 plus 3i and -2 minus 3i. Okay, so that's how you would work with imaginary solutions on a quadratic equation. Now, for the last part on this section, what I want to talk about is sometimes when you are working with these equations, you may have to simplify it before you actually start solving them. Like in this case, you can see they're giving it to us in the factored form, but this is not the same thing as x plus 2 times x plus 2 or x plus 2 squared. So you cannot apply the square root property at this point. What you will have to do is actually FOIL these two first, okay, and then write it as a quadratic equation, and then we will go ahead and solve it from that point. So the first thing we want to do is go ahead and FOIL this, okay, and that will give us x squared plus 3x plus 2 equals 10. Okay, so once you FOIL these two together, this is what you should end up with. And now you will see that your leading squared term has a coefficient of 1, so you don't have to worry about dividing it by any numbers. The next step we do is take the 2 over to the other side, and you're left with x squared plus 3x equals 8, 10 minus 2. Okay, now you will go ahead and take your middle term on the x term, take the 3, divide that by 2 and square it, which will, of course, you cannot simplify that any further. So 3 squared is 9, 2 squared is 4. So that tells us we need to add 9 plus 4 on both sides of our equation here, which will give us x squared plus 3x plus 9 over 4 equals 8 plus 9 over 4. Alright, let's go ahead and factor our left-hand side, which will give us x plus, would that be 3/2? That will work, okay? Because when you add 3/2 plus 3/2, you will end up with 6/2. 6 over 2 will reduce down to 3, because again, remember, we had seen the same exact formula a little bit ago. if you remember it. See, right there we had r squared plus 3r plus 9 over 4. That's the same thing we have here, only in terms of x, and even then we had factored it out into r plus 3 halves, and here you have x plus 3 halves. So very similar to what we had earlier. And of course you want to go ahead and add the right hand side, so you will have to find a common denominator, which would be 4. So go ahead and add those two terms and you will end up with 41 over 4 as the sum of this side. Okay. So you can see what the difference was between the original and now. The original was not a perfect square trinomial. You couldn't break it down into this form. Now that you have the x plus b whole quantity squared equals k format, now you are ready to apply the square root property. So that will give you x plus 3 halves equals positive square root of 41 over 4, or x plus 3 halves equals negative square root of 41 over 4. So of course you want to go ahead and simplify the 41 over 4, which will become square root of 41 over 2. Okay, you want to take the 3 halves to the other side, so they will become negative 3 halves plus square root of 41 over 2. Okay, same thing on the other side. You will end up with x equals negative 3 halves minus square root of 41 over 2, because again square root of 4 is 2. Now again, if you choose, you can try and write this over a common denominator. So your solution would be negative 3 plus square root of 41, the whole thing over 2, or negative 3 minus square root of 41 and the whole thing again over 2, and these will be your solutions to the original equation of x plus 2 times x plus 1 equals 10.